So let's go ahead and review. Today we're going to be looking at function notation. Okay, guys, time to quiet up. Henry?
Oh, I was checking my math. Wait, which one was the test?
Henry. Transformations, and then also graphing absolute value functions. All those concepts go well together. So let's go ahead and begin here. So find number 1 on your worksheet. Now there's 2 types of questions, and I want you guys to be able to distinguish between the 2 of them. When you have this where the number that they give you is inside, that means you plug in for x. So you plug that number in for x. But whenever you have this one, like number 3, for that one, what you're going to do is you're going to set the function equal to 5. So I'm going to do both of these, but just giving you a heads up. So there's 2 ways that I could ask a question for this. One is I could set f of x equal to 5. In that case, you set your function equal to 5 and solve. Or it'll be like number 1 here, where the number I give you is in parentheses. And what that means is you're going to take your function, 4x minus 5, and you're going to plug in the 4 for the x. Okay, so that's 16 minus 5, which is 11. Okay, so that's our answer for that one. So f of 4 is 11. I'll pause in case you're writing. Give you a few seconds. Okay. Next one, let's take a look at, I'm not going to do 2. I'm going to let you guys do 2. I'm going to do 3, though. Let's do 3. So for 3, solve for x, Jonathan, if f of x is equal to 5. So in this case, you're not going to plug 5 in for x. What you're going to do is you're going to take your function, which is 4x minus 5, and you make it equal 5, and you solve for x. So those are 2 different ways I could ask you a question involving function notation. After this, though, I think you guys know how to solve for x, so I don't think we need to chat too much about that.
Is it a graph or is it
So here's the next thing. I'll give you guys some time to copy this down. Just copy it down, maybe like on, I don't know, or whatever. So you might want to remember your transformations. So there's 2 parts to this. There's vertical and also put horizontal up there. So we do. So go ahead and either start copying that down, or if you have your notebook with you and you think you know where to find it, dig it out now. But I'll leave this up here for about 2 minutes, then I'm going to scroll down to the other one. So right quick. Once again, I'll give you guys like 3 or 4 minutes, copy this down, and then we're going to actually start some problems up. And yes, you do have this in your notes already, but I figured just in case you lost it, or if you don't have your binder with you today, you'll still need it, so we're taking some time. Go ahead. Let's do some problems here then. Okay, number 5. So what they do is they give you a function. It's our job to write a new function that has these transformations in it. Okay? So it says we're going to compress it vertically by a factor of 3. So look at your notes that we just wrote down. And it says vertical, right? So we're looking for vertical compressions by a factor of 3. So a vertical compression by a factor of a would be 1 over a. So for our problem that we're doing, what's it going to be? 1 over 3. And it goes outside the bars. So yeah. So I'm going to put 1 over 3 here and 1 over 3. That's a vertical compression. Next, it says translate it.
Did you not copy down the whole list you just had on the board?
The next one says translate it down by 2 units. So look at your notes. When you translate down, what do? You minus the number. So it's going to be like that. So here's your answer. Go ahead and box that. So we took our function, we multiplied it by 1/3. That's a vertical compression by a factor of 3. And the minus 2 is our translation down by 2 units. Okay?
Hang on.
So for those of you guys that are writing still, I'll talk a little more about this. So, but let's think about what happens to this thing as a graph. First of all, the shape of this thing is a V, right? So first of all, I took my V shape and I compressed it. So it got shorter, basically. And then I translated it down a few spaces. So it got shortened and shifted down. That's what those numbers do to the graph. All right. Once again, I'm going to do the odd one. So I'm going to skip 6 and move on to 7. So find number 7. Let's revisit our notes really quick here, because I realize the way they're wording it's different here. Can you guys find where you put vertical reflection and put reflect across x-axis? So where you put vertical reflection, put reflect across the x-axis. That means you're flipping it upside down over the x-axis, which you can also call that a vertical reflection. What do you guys think I'm going to have you write down here?
Like across the y-axis.
There you go. So reflect across the y-axis. So horizontal reflections, they're going to word it like this. Reflect it across the y-axis. Okay? So all right, let's return to our problem then. So it says we want to reflect it across the x-axis. What do you do in that case? Look at your notes. When you're reflecting across the x-axis, what do? Where do you put the negative? Inside or outside?
Outside.
Outside. So boom and boom. All right, so that takes care of this. Translation up 1 unit. Look at your notes there. What do you do if I want to translate it up 1 unit? Plus 1. Inside or outside?
Outside.
Plus 1, box it. We're good. So I took my cubic function. Some of you guys, if you did the extra credit, you know what cubic functions look like. They look like that. We're reflecting it and then shifting it up. So the final graph would look something like that, but we're not going to really worry about that too much. We're just looking at that. All right, let's do another one. That?
What's that check mark for?
That was just saying I did it. So I guess I could put another check mark there because I did that too. All right. We good? Really? Okay. Okay. Not sure. Sometimes people mess with me, so I'm not sure if it's serious. All right. Here we go. Go ahead and write down number, well, not write down, find number 9. So this one says we're going to go left 3 units. So when you want to go left 3 units, what do?
You go plus.
Plus 3, but where at? Inside or outside?
Inside.
Inside the parentheses. So check this out. It's going to be f of x equals x squared. So it's x
Plus 3.
plus 3 on the inside. So in this case, that plus 3 goes inside a set of parentheses with your x there. All right. What about the translation up 2 units? What does that do?
Plus 2.
Plus 2, where at?
Outside.
Outside. Here's our answer.
Mr. Bailey, and what unit is this worksheet gonna go into?
It's not. This is just you guys are gonna turn this worksheet into me. I'm gonna grade it and hand it back to you as soon as I can. So you guys are gonna use all these as a study guide for your finding. Okay. All right. I'm gonna do what?
We're gonna get it.
Homework. All right. Let's keep going. I just want to do a few because there's so many different kinds of transformations out there. So let's take a look at number 11. All right. So this one says reflect across the y-axis. So when you reflect across the y-axis, what do? A negative inside the parentheses. So now that negative is going to go inside the square root as well. Translate to the right 1 unit. What's translating to the right going to do?
It's gonna make it white.
Minus.
Well, I mean, like we do -1, right? So, and is it inside or outside? So it's x minus 1 on the inside. So now we put a -1. That translates us to the right by 1 unit. What else?
Minus 3.
That's right, -3 on the outside. Translating down is -3 on the outside. So now we have this. What's that?
Oh no, I'll just.
The double parentheses is weird.
We have to.
Yeah, but the test will be multiple choice, so you don't. If you forget, it'll be on the test. So
Okay.
it's not a huge deal, but yeah, you want to write it like that, technically. So there we go. That's our final answer. So I boxed the final answer. Huh?
Like remember Elf on the Shelf in the house? And like petrify those things if I see them. Don't be on the one
I suppose they're a bit creepy.
Big?
A bit.
Those things are scary.
Those are horrifying.
That's like a tiny piece of Satan.
My sisters won't refuse to touch the fan for like the entire day because it's been hanging from this spring somewhere else.
Is anybody else still writing this?
Yeah.
Elf on the Shelf.
I'm afraid of it.
All right, let's see. Do I have another one of these? 13. So here we go. If I were to translate left 1 unit, what is that? Plus in the parentheses. And down 1 unit. So I think you guys have got it pretty good. So this is that translates it left 1 unit, and that one. Oh, I forgot my -1 here.
Yeah.
All right.
My sister just said he's afraid.
What?
Okay.
We're doing 15?
Yes, number 15. All right. So
Do you like my pen?
now these ones I made multiple choice. For these types of questions, you guys, the blue one, think of that as your original function, which is g of x. Now, what would you have to do to this blue line?
Our thing doesn't have colors.
That's okay.
Solid line and the dotted line.
Solid and dotted. So, thank you. So, what would you have to do to this solid line to get it to look like this dotted line? You'd have to do 2
Oh, you have
things.
to flip it.
You'd have to flip it which way?
Left.
Horizontally or vertically?
Horizontally.
It actually could be either one, I just realized. But
Oh yeah, because you could go.
they look the same. But what else would have to be done?
You have to translate it, so you have to put plus, which makes it go left.
Okay, good. So we see that it's been shifted how far over?
1, 2, 3.
3 spaces over, right?
You have to put plus
And it's +3, and it's been flipped. So we should see a +3 inside the parentheses and a negative. Which one is it?
Mr. Bailey, wouldn't it be -3?
It'll be C.
Oh, you're right. It's to the right, huh?
Yeah.
So it's -3, not +3.
What?
So she's right. So which one is it?
No, but isn't it the opposite? Like, if you want to go.
No, she's right because subtracting 3 on the inside moves it to the right. So, and then you flip it. So it is B. So there's your flip, the negative.
Wait, which
This
one?
is what we did pretty much on like 2 weeks ago.
We've done, this is all review. Yeah.
No, but because on that it was
Are we trying to make it the dotted line or the solid line?
So what if you check that?
No, that's wrong.
Oh, okay.
No.
Direction
Negative
is
is
still
on the
same.
inside is to the right. positive is left.
John, if you turn around, your right hand's still your right hand.
All
That's
right,
what I'm talking about.
let's do another one.
Did you just
That's an even one.
He just figured out it's turn around.
Oh, you're right.
Where's my?
Okay. So what do you guys think happened here? So here's my solid line g of x. What would I have to do to g of x to make it look like the dotted line?
+3.
+3 inside or outside?
Outside.
So it's been shifted up, so we know we need to add 3 to the outside. And it's also been what? Reflected over the y. So where am I going to put my negative? Inside. So which option is it? Which one has a negative on the inside and moved up 3? They're using different letters than me. It's D. It's not A because the 3 has to be outside the parentheses. Oh, I see why I wrote the wrong letters, because I'm calling this G, but this is actually supposed to be F, so I'm using the wrong letters.
Wait, so the F is the solid line?
Yeah, so it says G is the dashed line, F is supposed to be the solid line, so I'll try to correct that in the future. Sorry.
Flip it up 4.
You don't flip it, you slide it up 3. It's up 3, it goes from here to here, and then it's
Oh, okay.
sideways.
Yeah, my bad. Yeah.
So D is the correct answer there. All right, let's do another one.
19?
So here's my function.
No, it's 19.
All right, what would you guys say has happened here?
Hey, Mr. Bixby.
That's even.
Flipped across the x-axis, so what do we do? Oh, is it even?
Yeah.
Oh, my bad. We're doing odd, sorry.
Wow.
All right,
You didn't want to listen.
Fernandez.
okay, so what's one thing that's happened here? It's definitely flipped, so is my negative inside or outside? Has it been flipped vertically or horizontally? It's vertically, so it's outside. Now, you also notice that it's skinnier, right? Now, there's 2 ways that you can get a graph to be skinnier. One is by stretching it vertically. So I could have a number out here like this. Or another way you could do it is by compressing it horizontally. That will also make it look skinnier. So it could be this. So which one do you guys think it would be here? C. Good. It can't be the ones with fractions, right? Because that's for the opposite, and it's been flipped. So the only thing is we don't know what the number is here. We don't know how much is being compressed or stretched. All right. I think we have one more of these, if I'm not mistaken. So what do you guys think happened here? Being flipped across the y, so where does my negative go?
Inside.
Inside. What else? It's been shifted over, right? To the right.
Yeah.
So when you shift something over to the right, what do you get?
Minus.
You get a minus on the inside, right?
Yes.
And what else?
Close parentheses.
Look at the shape. You guys notice the shape's a little bit different?
Oh yeah, it's more flat.
It's either been compressed vertically or stretched horizontally. So it's either this or it could be this stretched. Yeah.
Yeah, it's compressed.
So which one? Which option am I going to pick here?
A.
A? There it is. We have our fraction on the outside. We have our negative and our -1. So you're right. Yeah. What was it? What was the answer for 19, guys? C. Thank you. All right. So I have a little bit more I can do. So let me ask you guys a question, though. Oh, here's another one.
Yeah, 23, 25, and 27.
What do you guys think this one is? I'll let you go ponder for a minute. See if you can figure it out. So it is A because the +3 shifts it to the left, and the negative would flip it, which has been flipped. So there you go. Okay. So we have an option here. Do you guys want me just to keep talking? I don't like talking to students this long because you kind of just zone out and get tired. But some of you guys are still tracking with me. Or do you want me to finish it? Because here's the thing. I can finish these two now, and then you guys can just finish the rest of the homework, or I can do the video and let you guys practice with the rest of class with what we've done.
Video.
You guys how many of you guys want me to stop talking right now and you guys can watch the last two on a video tonight? How many of you guys want me to just keep teaching right now? Okay, so I'll just finish it up. I don't like talking this long, but try to change things up next time. Okay, so these are absolute value functions here, guys. We learned how to graph these. When it comes to absolute value functions, you might want to write this little note here on the side. These two numbers make up your vertex, but don't forget, this number is always going to be opposite sign, right? And this is your slope. But remember, when you do slope with an absolute value function, you go up, and your run is always left and right, not just up and over. It's up and left and right. That way you get that V shape. Okay. So in this case, what's my vertex? We're missing the number on the inside. What would that be? 0. And so my vertex is 0, 1. And my slope is 1/3. So I'm going to go up 1, right and left 3. Ready? 0, 1 is here. We're going to go up 1, right 3, up 1, left 3. Connect your dots with your V shape. It's a compressed absolute value function that's been shifted up one space, right? So I only have one more after this?
Mhm.
Nice. Nice. It was a good call to let me keep teaching because this won't take very long. Okay. Okay, let's do the last one, and then the last 10 minutes of class, you guys can just start your homework up, and here we go. So first of all, I'm going to rewrite this so everything's there. So I don't have a number in the front. What's the number in front if it's not there? 1. And we don't have a number inside the parentheses, so that's a what?
Wait, that's 26.
Yeah.
Oh, am I doing the wrong one again? Dang you, Mr. Bailey. There we go.
Oh.
All right, we don't have the number in the front. So what is it? 1. And we have all the other numbers. So what's my vertex?
Hang on.
Close.
Negative is 2.
I think you said it right. He said it wrong.
Oh. Yeah, it's
What?
-2.
It's
Negative 2.
positive 2.
Nah, but the original equation is x minus 8.
Mm-hmm. And my vertex was positive h, right? So you always do the opposite for this one.
Right.
Right?
That's always been on.
No, but the original equation is a, and then the whatever those things.
I'll look at it with you, but I'll show you. So my vertex is 2, 3. My slope is 1, so I'm going to go up 1, right 1, up 1, left 1, and there you go. So we're done. The rest you guys can work on now until the end of class if you want to, or you can save it for homework. That's up to you.
I want to see